that symbol means similar, something like that. So similar means it's the same shape, but it's not the same size. Okay, that's what similar means. Same shape, but not the same size. Unlike when we said congruent, congruent is the same shape and the same size. And we'll use this symbol for congruent. So that symbol right here, without the circle, that's similarity, and this is congruency. Congruent and similar. So if we make this triangle here, I make a triangle like that, and let's say I make a smaller triangle. Well, if I say they're similar, they're the same shape. They can all be equilaterals. Now, it's very important. Here's the first, I'll put a star right here. Similar triangles have the same, and we'll say congruent, the same angles. And what I mean by same angles, I mean they have congruent angles. Very important. Okay, and now another vocabulary we'll talk about is corresponding. Corresponding. Corresponding, and I'll give an example here. Let's say that this was an 8 and that was a 5. Well, 8 and 5 are corresponding sides because they're in the same location on the two triangles. That's what corresponding means. They're in the same location and they're proportional. So corresponding sides are proportional. Okay? So let's look at a few examples of similar triangles and how we can use proportions to solve them. So I'm going to make let's say I make a right triangle here. Right? And I'll make another one over here. And we can say that they're similar. So if they're similar, they have corresponding sides. So we can say, let's say that this was x, because we didn't know what it was. We just call it x. And let's say this side was 4. Say 4. So we know that x and 4 correspond to each other because they're in the same location on their corresponding triangle. And then let's say that this was 8, and we'll say that this was 3. Something like that. We can make a proportion to find what x is. So what we do is we can say x over 8, and then make another ratio that corresponds to the same location. Well, we're saying x over 8, so then we should say 4 over 3, because right? Because the 4 corresponds with the x, and the 3 corresponds with the 8. Then all we have to do here is just cross multiply. So we're going to have 8 times 4 is 32, and we're going to have x times 3 is 3x. So just divide. We'll divide that out, and we'll get what x is, and we can place it over there. So what do you think x is? Right, so 9, because 9 times 3 is 27, so we should go a little further than that. If we use 10, we'll get 30 and 2/3. So that'll be x, 10 and 2/3. So we'll just say 10 and 2/3. We found x, 10 and 2/3. So let's do a few more. All right, so let's draw another triangle here. Let's say I have something like this. And we'll put some angles in, and we'll make a similar one. Now I said in the beginning that similar triangles have congruent angles. They'll be the same. So we know that that's a 90-degree angle. That's 90, so this has to be 90. And if this is, let's say this is 40 degrees, then this has to be 40 degrees because they're corresponding. And they have proportional sides. Right? Not corresponding, but congruent. They're congruent. And they're also corresponding. The 40 corresponds to the 40 over there. So let's put some letters to represent each angle. Let's say that's angle A, that's angle B, and that's angle C. And then we'll do another one over here. We'll say that's angle D, angle E, and angle F. So we know that angle AB corresponds, angle AB, side AB, sorry, side AB, A and B, side AB corresponds to side DE. So what would correspond to side BC? What would correspond to side BC? Side EF, right? So we don't know what they are. We didn't put number lengths in them, but side EF is here, and it corresponds to side BC. Now we also can say side DF, right here. What does that correspond to? Right? So it corresponds to DFAC. AC. And then also we can put anything, we can say, well, DF and EF would correspond to AC and BC. Just make sure that you have the same correspondence going on. So again, make sure you know they have the same angles. They're congruent and corresponding sides that are proportional. And let's do another one. So a lot of times you'll see where you have a building, let's say, or a tree. Let's just make a building. Right? Somewhat of a building with some windows and so forth. And let's say that the noon sun or the afternoon sun makes a shadow. And let's say this shadow is 20 feet. So the shadow of the building is 20 feet, but we don't know the height of the building. We just can't get a tape measure up there. And what you can do, and you can also do this at home, let's say this is your height or your friend's height, and you have a shadow. You cast a shadow. Let's say your shadow is 4 feet. And your height, let's say your height was 5 feet. So we have your height, the shadow's height, the shadow of the building's height, but we don't know the height of the building. As you can see, we're creating these triangles here. And what we can do is make proportions. We make, that's what we have. Let's see. We have 5 over 4. That's one proportion. 5 over 4. And we want to put that corresponding ratio. What corresponds with the 5? The x. Right? And what corresponds with the 4? The 20. Right? Let's move that 20 out of the way and bring it over here so we don't confuse ourselves. So now, again, we have our corresponding ratios, and we will just cross multiply. And we're going to have 4x equals 100. 20 times 5 is 100. 4 times x is 4x. And if we divide out the 4, doing some algebra here, we will get the height of the building. Okay? Yeah. And you should know that x would be 25. Right? 100 divided by 4 is 25. Right? There's 25 quarters in a dollar. So the height of the building is 25. Again, we're doing similar triangles here, and we can do proportions to find missing sides. All right, let's do one more on the whiteboard. All right, so here we have 2 triangles, and they're similar. Remember that symbol for similar, that little squiggly line right there. So if they're similar, we did say that they have corresponding sides that are proportional. And we know that 16 and 4 are corresponding. We know that 3 and this side is corresponding, but we don't have a number there, and we'll get those numbers. They also have congruent angles. So if that's 110 right here, then it has to be 110 there. Simple as that. And if this is 40, then that angle has to be 40. So what do you think this angle is? They're missing on both. But we know that a triangle has 180 degrees. So this has to be 30 to make 180. And if that's 30, that has to be 30. So again, very important. They have their angles are congruent, means same shape, same size. Similar is just same shape. So now let's look at these lines for a minute. We have a line here. A to B is line AB. Right? And we know that line AB is 16. It says 16 right there. So let's say we have line AB, and then we do a ratio of line AC. So what is AC? Right there, it's 24. Right? And let's say now we're trying to find DF because it's missing. So what we can do is set up equal proportions. What corresponds to AB on the other triangle? Here's AB. Right here, DE, right? So we need DE. And we know that DE is right there, 4. Now we have to have the same corresponding ratio. We used AB and AC, so we need to use DE and DF. Well, we're trying to find DF, right? We don't know. We have an X right there. So now we can rewrite this. Let's get a clean sheet of paper. Bring this up. Okay. So remember we said line AB and line AC is 16 over 24. And we said line DE and line DF is 4 over X. So now we're saying 16 over 24 equals 4 over X. And we can find X by doing cross multiplication, right? So we're going to have 16 times X is 16X, and 24 times 4 is 96. So just divide on both sides, right? Because we want to isolate the X, and X is 6. So now that we know that X is 6, let's go back to our triangles. DF is 6. Okay, now we have everything. We have our 4, 3, 6 triangle right here, but we're missing this one. So how can we get this line, line BC? Well, let's look at it. So look what I did here. Let's bring back the triangle for a minute. BC is corresponding to EF. EF is 3. So EF is 3. BC we're trying to find. That's why we put an X there. They're corresponding, right? And then we used any information that we have. We could use DF or we can use DE. You can pick whatever one. You only need one more. If we use DF, that means we have to use AC on the other one because we have to be corresponding. So here I used DF, it was 6, and AC was 24. One more time that you see it. Right? EF is 3, DF is 6, AC is 24, and we're trying to find BC. All right, so what we have is we have 3 over 6 equals X over 24. We cross multiply, as we always do. 6 times X is 6X. 24 times 3 is 72. Fix that 7. We divide out to 6. Whatever we do to one side, we do to the other. And X is 12. So we have all our sides. We did that using proportions. So now BC is 12. And that's similar triangles. That's how we do similar triangles. So again, you should rewind the tape. Look at our examples. Remember, similar triangles have the same shape, but not the same size. If they had the same size, they would be congruent. But they do have congruent angles. And a triangle must equal 180. So keep that in mind and have a great day.